All right, so there's several special product forms that can be used that are just patterns as far as identifying the expansion into a polynomial. The first is called the sum and difference of terms. When you're dealing with the sum and difference of terms, what that means is it's a set of factors that have the same two terms, a and b. The only difference is one separated by a plus, the other separated by a minus. If you were to FOIL this out, again, your first is a squared, your outer is negative ab, your inner is plus ab, and your last is negative b squared. When you look at this, what's going to happen to the outer plus inner products always? They're exact opposites of each other, and so they wind up canceling out. If you recognize this, it allows you to answer this type of question extremely fast, because you're just going to square the first term and subtract the square of the second term, and that's your answer. So if I ask you to expand x plus 5 times x minus 5, and the way that you can answer that, again, very quickly, is just to recognize it fits into this pattern. Since that's the case, you can apply it. It just becomes x squared minus 25, or x squared minus 5 squared, which would give you the x minus 5, or x minus 25. So if we take our first term, square it, minus the second term, squared, again, you can do that with a mental calculation to get your solution. And even if you have terms in front of your variable, if it fits this pattern, okay, so here it is, the product of two factors. They're the exact same terms, one separated by a plus, one separated by a minus. And in doing that, it fits this pattern, so all you have to do to expand it is take the first term and square it. So what is 3x quantity squared? Square the 3, you get a 9. Square the x, you get x squared. And then always a minus, and then 2, when you square that, is a 4. And so you get your solution, again, really quickly in this form. All right, one more pattern to take a look at is the binomial square pattern. Right, and the binomial square pattern says if you have a binomial, or two terms, whether they're added or subtracted, and you square it, the pattern that it fits into is you'll take your first term and square it, then you'll take the product of these terms and double that. So a times b doubled is 2ab, and then you're going to add the square of the last term, so the b squared. And again, if this fits your pattern, it allows you to expand one of these expressions much more quickly than even entering it in your calculator. So if you were given something like this, x plus 1 quantity squared, the pattern is square the first term, take the product of the terms and double it, so x times 1 is 1x, double that, you get 2x, and then take your last term and square it, 1 squared is 1. Once again, this works for numbers other than, with a coefficient other than 1 in front of the x. So if you recognize that you have a binomial square, again, if you square the first term, so 2 squared is 4x squared, take the product of these terms and double it. 2x times 3 is 6x. When you double that, you get 12x. And then square the last term. 3 squared is 9. And so you get your expansion just by using the pattern rather than having to type it all in. This works with negatives as well. If you're dealing with a negative, you simply treat your negative term, treat the negative as part of this b value that you're applying in the pattern. So here you have a binomial square. So you're going to square the first term, 7 squared and y squared. You're going to take the product of these terms. 7y times a negative 2 is negative 14y. When you double negative 14y, you get negative 28y. And then square your last term. Negative 2 quantity squared becomes a positive 4. So the negative sign does take care of itself, even if your second term, your b term, is negative. it still fits right into that pattern. All right, questions on this? Yep, Harrison. Expand. Yeah, so let's say if we were entering this in our calculator, so let's say we wanted to verify this bottom equation. Okay, so if I typed in 7y minus 2 to the power of 2 and hit enter, it leaves it as factors. So again, whether that happens or not, or even if you enter something and it happens, when you expand, your answer needs to be written as a polynomial. So if it doesn't, with whatever operations you choose, make sure you go back in and change it, put the expand function in front of your expression, and then you can, again, see that this verifies what we got by hand. But yeah, you do want to use expand for that.